This training course content is brought to you by Daedalus Aerospace. For on-demand flight test training, please visit daedalusaero.space. In this section of the Daedalus Aerospace course on building test cards, I'll share a few examples of flight test cards in a sort of test card art gallery. Hopefully, by looking at some example card formats, you can apply some of the ideas taught in this short course. I'll show some good examples and some bad examples. Keep in mind that there are no perfect test cards, and there is no one format that is ideal. The actual procedural steps on the test cards, plus of course the setup conditions and safety mitigations, must come from the specific test plan that you are using. Here's our first example test card. It's a test card for stall testing, printed in the publicly available U.S. Naval Test Pilot School Flight Test Manual 103 on fixed-wing stability and control. It's a great text that covers both theory and flight test techniques. The style of this card shows a sort of combination of elements that I described in other parts of this course, including both a cover card and a data card format. The U.S. Naval Test Pilot School Flight Test Manual number 103 includes a brief description of test card construction on page 2.28, and it says, the final step in pre-flight planning is the preparation of pilot data cards. An example of a stalled data card is presented here. However, most test pilots desire to modify data cards to their own needs or construct data cards for each test. At any rate, the data cards should list all quantitative information desired and should be easy to interpret in flight. For stall investigations in particular, several data cards with adequate space for pilot comments should be provided. Now, as I discuss the layout of this test card, think about which essential elements of test cards you notice included with this example. And if you haven't downloaded the course handout of test card data fields, it's attached in the course player below this video. The top section of this card includes typical elements for a cover card. This line of the example card indicates that more stall tests could be planned at other configurations. Flaps, gear, thruster power settings, etc., and at different altitudes. These are fields for recording handheld data during setup for the stall test point. They are most useful if you don't have a test aircraft with a data acquisition system or video cameras, so you can write down test conditions as they are flown. You could record a lot of stall test data using this test card, but will you fly the stall test procedure correctly? That depends on the flight test brief and a shared understanding of the defined stall test technique to be flown, because, as you can see, there's no procedural information listed as far as exactly how the flight test technique should be flown. That would be expected to be briefed before the flight and documented somewhere else. So are there any ways to make this card better? The thing that stands out to me is that the data fields are rather open-ended. So I think maybe adding some qualitative multiple choice prompts that you could simply check a box, or a scale of results so the data could be recorded by just making a mark rather than writing a number. The next two test cards are from the U.S. Air Force flight test mishap of the B-1A, tail number 74-0159, on its flight 2-127 on 29 August 1984. These test cards were sourced from the personal records of Captain Otto J. Wanizak, Jr., the Air Force Flight Test Center flight test engineer that was a crew member on this B-1A mishap flight and one of the survivors from the capsule bailout. Thanks very much to Ken Katz of Collins Aerospace, a former B-1 test crew member, for sharing these test cards and providing his analysis. If you want to learn more about this accident, Ken's technical paper describing the accident and analyzing the causal factors is attached for download below the course video. The B-1A mishap occurred during the transition from one test point to the next test point. Test planning, test hazard analysis, system safety review, test cards, and real-time monitoring in the cockpit and mission control all tended to focus on the test points themselves and not the transitions between the test points. So as we discuss these cards, think about what essential elements of test cards you notice are included with this example and what elements might be missing. On the left, we see flight card 14, the test point that preceded the loss of control. And on the right is flight card 15, the transition to which was in process when control of the B-1A was lost. Both these test cards are for minimum control speed, with card 14 testing static VMCA and card 15 testing dynamic VMCA, which is a somewhat different flight test technique, and also they were going to test in a different configuration. Notice that the test conditions for both these cards are at a fairly low altitude, which is necessary for data quality of VMCA tests. Remember that the ground elevation in the vicinity of Edwards Air Force Base is approximately 2,500 feet. So these slow-speed, high-thrust asymmetry tests are being set up below 5,000 feet AGL. Most test organizations would classify these sorts of tests as elevated risk, which should factor into the test communications and an emphasis of crew resource management during test execution. Note that there are 4 configuration changes for the aircraft between flight cards 14 and 15. Landing gear, flaps and slats, wing sweep, and longitudinal center of gravity expressed in %MAC. Nowhere in the test card does it specify the order in which these 4 changes should be made. This was the critical oversight, and it's why I taught the section earlier on critical thinking and the defensive mindset. Sweeping the wings forward before moving the longitudinal center of gravity forward created an out-of-envelope condition, which was the causal factor for loss of control. It is a basic standard of aircrew professionalism to have checklist discipline. The flight test community's emphasis on following the test card and not doing things ad hoc is an extension of professional aircrew's emphasis on checklist discipline. The belief in the desirability of checklist discipline is based on the assumption that the checklist contains the best, thoroughly reviewed, and formally approved procedures. In the case of the B-1A mishap, the lack of specific order of configuration changes between test point 14 and test point 15 meant that operating in full accordance with the test card actually had a catastrophic consequence. The additional factor was lack of attention and mission control to the transition between flight cards 14 and 15. Prior to the mishap, the aircrew repeated flight card 14 because the first attempt did not have adequate data quality. The mission control team took advantage of the downtime between transitions between flight cards 14 and 15 to review the data from the second attempt at flight card 14. Those personnel not reviewing flight card 14 data were working to stay ahead of the aircraft by preparing for flight card 15, and although mission control personnel had the data for wing sweep angle and longitudinal center of gravity available, in theory they could have advised the aircrew of an impending out-of-envelope condition. Nobody was actually monitoring the transition. So this also factors in with what I was talking about in another section of the course about having specific flavors of test cards depending on the responsibilities of that crew member. And so you can sometimes have more elaborate descriptions of the test procedure, things that should be checked for the control room or for a specific member of the control room than you might have sitting on the pilot's kneeboard. What essential elements of test cards do you notice included with this example? Are there any elements missing? I hope you've noticed the lack of safety mitigations and cleanup items after card 14. Our third exhibit in this gallery of test cards was published in the NASA Aerospace Engineering Handbook, Chapter 2 on Flight Test Engineering by Kate Pavlock. This card is for the NASA Gulfstream G3 Aerodynamics Research Test Bed shown in the lower left. The test card shows the style of a test point maneuver block, which lists the test points but without detailed maneuver descriptions. I discussed this style of test card earlier in the short course, and you should keep in mind that the maneuvers should be described in greater detail somewhere else in the card deck, in the test plan. They should be briefed more specifically in order to get useful test data. The test plan could describe the test procedure that's to be flown. Notice the detailed setup condition information at the top 1/3 of the card and a brief synopsis of a safety-related caution. What essential elements of test cards do you notice included with this example, and are there any elements missing? The final examples I'll show you are my own test cards that I made as a U.S. Air Force Test Pilot School student, and they were built for my F-16 Systems Test Check Ride that was in the syllabus at the time I was a student at the Air Force Test Pilot School. Point of that check ride wasn't actually to reevaluate the F-16 systems. Those are rather well understood at this point. The point of the check ride was to build and execute test cards that collected high-quality data to meet certain requirements of a test plan that was provided as part of the check ride assignment. Every student test pilot made and flew their own cards for this check ride. I sized my cards to fit my kneeboard in order to provide detailed guidance for flight test execution while also leaving me room for notes and data collection. One of those system test check ride requirements in that notional test plan was the evaluation of controllability of the jet during a simulated weapons delivery, including use of a Cooper-Harper handling qualities rating scale. That's what you see in card number 7 on the left. You can see the setup and limits in the top of the card, procedural steps 1 through 12 in the main section, task performance definition, and room for me to write down ratings on my assessment of my ability to control the aircraft, the airspeed, and the fire control radar during the test. Now, should my step number 12, listing master arm to safe and cursor 0 twice, have been a cleanup step at the bottom of the card? I'll let you decide that. The other card shown, card 10, is from this same U.S. Air Force Test Pilot School check ride that I flew as a student, and it's a good example of a pilot comment prompter that I also discussed earlier in this short course. While this sort of questionnaire could be completed after the flight, it's usually best for data fidelity to get the answers in flight immediately after having flown the test. Burning a little bit of extra fuel while you're running this sort of card is worth the expense because it will also serve to capture pilot comments that can often be the best data for validating or refining a system design. So what essential elements of test cards do you notice included with this example? Any elements missing? In conclusion, flight test cards are simply a tool for a task and are almost always custom built for the flight test mission. In flight test, there are no pre-formatted recipes to follow. However, by using the principles taught in this course and considering how to include some essential elements of information, we can prevent most mistakes and significantly improve the likelihood that our flight test missions will safely and efficiently result in useful data. Daedalus Aerospace offers on-demand flight test training courses on topics your team needs, including flight test data analytics using Python, flight test risk management, and telemetry ground stations. For more information, please visit daedalusaero.space.